If the first premise of the argument is I horseshoe H dot not S, and the second premise is H dot not S, and the conclusion is just I, your table should look like this. Since there are three letters that appear in the argument, I, H, and S, we write those letters over here. This part of the table is where we keep track of the possibilities for the component sentence letters. For three letters, there are 8 possibilities. Notice the innermost column alternates true, false, true, false, true, false, true, false. The middle column is 2 trues, 2 falses, 2 trues, 2 falses, and then the outermost column is 4 trues and 4 falses. If there were a fourth letter, there would be 8 trues, then 8 falses, with these same 8 possibilities repeated down here. Now we're ready to start filling in the values on our table. For the first premise, we have to start inside parentheses. The whole sentence is a conditional, whose consequent or second part is a conjunction. That conjunction combines the value for H and the value for not S. We have the values for S over here, but first we need to get the values for not S. On the top row, S is true, so not S is false. Since on the second row, S is false, not S is true, and so on down the column. Now we're ready to do the conjunction. Look at the value for H over here. On the top row, it's true. We already calculated that the value for not S is false. A conjunction where one input is true and the other input is false is false. In fact, conjunction is false whenever at least one of the inputs is false. On the second row, H is true and not S is true. 2 true inputs makes a conjunction true. Here we've got a false input, a false dot false, that's false. False dot true, that's false. True dot false, that's false. True dot true again is the only way a conjunction can be true. False dot false is false, and false dot true is false. Now we've got the values for conjunction, and these values are useless to us. We only use them to calculate these values. Now we're ready to tackle the conditional. Remember, the only way a conditional sentence can be false is if the first part's true and the second part's false. Otherwise, it's true. On the top row, I is true, so we've got true horseshoe false. That's the way a conditional can be false. We've got true horseshoe true on the next row, that's true. True horseshoe false is false again. True false is false again. And now we've got a false antecedent. Anytime a conditional sentence has a false antecedent, it's true. So we can put T's all the way down. Now, H dot not S is a separate premise. It turns out that we've already calculated the value for H dot not S when we did the consequent of this conditional. I'll repeat it again, but you'll find that we get the same values that we had here. Remember, not S is the flip of the S column, so false, true, false, true, false, true, false, true. Conjunction is only true if both inputs are true. So on the top row, we've got true dot false, that's false. True dot true is true. False dot false is false. False dot true is false. True dot false is false. True dot true is true again. False dot false is false. And false dot true is false. Again, this column doesn't matter anymore. We only used it to calculate this one. Now the conclusion is just I. Since there's no operation, there are no symbols here, we can just copy the I column over here. There are 4 trues and 4 falses. Now I'll separate the conclusion from the rest of the table with 2 lines. And remember, now that we've got the right values on the table, the only thing left is to read our table. Now what are we looking for? If we're checking for validity, we're trying to make sure that the argument doesn't have or can't have true premises and a false conclusion. The values for the first premise are represented in this column. We only calculated these to get that column. The value of the second premise appears in this column. So what we're looking for is a true, true, false. If the argument's got any row like that, then it's not valid. If it has no row like that, then that arrangement is impossible and the argument is valid. So we don't have a true, true, false on the top row. That's okay. We don't have a true, true, false on the next row. We don't again on the next row or on the next row. We don't have a true, true, false on this row because of this false. That row's okay. But we do have a true, true, false here. First premise true, second premise true, and the conclusion false. So if you were asked to come up with a scenario that makes the premises of this argument true and the conclusion false, it would be a scenario that makes I false, H true, and S false. This row shows this argument is invalid.